Hello.
Hello.
So this is where you can draw some really nice circuits?
Yeah, this is the place. Why do you ask?
Well, I'd like to make 2 electrodes with a gap as small as possible.
Well, with electron beam lithography here, we can go to 100 nanometers, perhaps even lower.
Really? Could you do that for me?
Even better, actually. Sit down. I'll show you, and then you can do it yourself.
The construction process begins with a circuit design, which is quite straightforward through a computer interface. Here we are demonstrating the design of 2 interdigital electrodes. The whole circuit is 200 micrometers large, with a gap between the electrodes of 500 nanometers. The circuit is made on a silicon plate. The first step is covering the silicon wafer with a thin layer of polymer, which monomerizes when exposed to the electron beam. With the use of a spinner, a uniform thin coating of a few hundred nanometers thickness can be deposited over the silicon. The polymer is then hardened by baking it at 200 degrees centigrade. When the wafer is prepared, it is inserted into the electron microscope, where the circuit is drawn. The electron beam precisely follows the design of the circuit and only irradiates the previously defined parts of the wafer, where the electrodes will be. When we take the wafer out of the microscope, we put it into a solvent to develop it. The solvent is chosen only to dissolve and remove the parts of the polymer which were irradiated by the electron beam, and leave the rest of the polymer film intact. After the wafer is cleaned, it is ready to move to the next stage, metal deposition. The wafer is placed into the sputter. This device sputters the metal over the whole surface. On the parts where the circuit was drawn and the film dissolved, the metal can stick directly to the silicon, while everywhere else there is still a polymer film between the metal and the wafer. The final step is removing all of remaining polymer together with the unwanted metal. The wafer is put into a different solvent which dissolves the polymer. The metal on the polymer also floats off, while the metal that is directly on the silicon wafer stays intact. And the result are 2 very small and precise electrodes.
You see, it's not that big of a deal.
Great. Then let's go and do it right away.